All right, this is Mr. Kyle, Myers Mathematics, and let's just jump into it. This is number 12. I had to skip a few. So if you're watching this and you're not the student, then you're probably going to be a little bit confused by this. But I skipped a few from the other one because I just remembered that we did a bunch of the ones that I was making videos for already. So I'm pretty sure we left off on this one. But I don't know. I'm probably going senile. I don't know. We definitely probably maybe did this one. I remember one of them was out of order. So we're just gonna pick up at 12 and we're just gonna go from here. we're supposed to find all the complex zeros of the polynomial function and write the polynomial in completely factored form. So it is in order, so that's nice. It's got the x to the fourth, then the x to the third, x squared, x to the first, and then the constant, which would be x to the 0 power. So that's good. If there were any gaps or if it was out of order, we would need to fill the gaps and put it in order. Okay, so we don't have to deal with that. That's good. They want all the complex zeros, which means they want all the zeros. Basically, if they want all the complex zeros, then we're looking for the degree amount of zeros. So the amount, let me write this over here, the amount of complex zeros, and this would include multiples. So if there is a multiple, we would count it more than once. Amount of complex zeros is going to be equal to the degree of the function. Degree of the function. So because this is a fourth degree polynomial, we are expecting 4 complex zeros. And again, some of those could be multiples, like if a certain zero goes in more than once, we would count that more than once. But there are going to be 4. So let's go ahead and see what we can do. It's going to be all the rational zeros would be all the factors of 5, so plus or minus 1 or 5, over all the factors of 6 or negative 6, which are going to be a lot more, plus or minus 1, 2, 3, and 6. That's a lot of different things to check. However, the nice thing is that we're probably only going to need to check like 1 and 2. So I'm going to move this over a little bit. That way I can do my synthetic over here on the left-hand side. So we're going to just try 1 and see what happens. These signs switch a lot. Here's another thing that you may or may not have learned in class is possible positives versus possible negatives. If you see a lot of sign changes, like it goes from plus to minus to minus to plus to plus to minus, then there's a pretty good likelihood that you'll have a possible positive zero. If you don't see a lot of sign changes, then you probably have it's more likely that you'll have a negative zero that works. Okay, there's a lot of sign changes here. Not a lot, like it's not like every other, but it does change quite a bit. So I'm thinking that 1 might work. I'm going to pull out the coefficients. And I like to put little bars here. I don't see a lot of people doing it this way, but I kind of like it because in that way I don't get any number confused with any other number. And there we go. And I like to put a little line here too, because I'm going to be adding going down. So I add going down, and then going diagonally, I'm going to multiply by the number in that little box. And you always see them write it like this. I've never seen them write it a different way, but if you wanted to, you could write it a different way. I mean, you could put it in an actual little box. I usually call it a box. Other people call it a box too, but nobody ever actually puts it in a box. It doesn't matter how you draw it, right? It just matters that you know what that number is in that little box area. Okay, so we're gonna add negative 6 to nothing and get negative 6. Negative 6 times 1 is negative 6. 19 minus 6 is 13. 13 times 1 is 13. Negative 15 plus 13 is negative 2. Negative 2 times 1 is negative 2. Negative 3 minus 2 is the same thing as negative 3 plus negative 2, which is negative 5. Negative 5 times 1 is negative 5. 5 minus 5 is 0. Haha, it does work. Okay, cool. So it says write the polynomial in completely factored form. So let's get a list of these zeros. So we've got, so far we've got, for answers here, we've got zeros of 1, so far, which would be f of x equals, and then we'll have an x minus 1. Okay, so I'm going to go ahead and just start getting ready for the answer, right? Rather than just doing synthetic over and over and over again, let's pause each time and celebrate our wins. So we've got a 0 of 1 so far, which would be an x minus 1 in factored form. Okay, well, let's try a 1 again. Just because 1 worked doesn't mean it won't work the next time. You know it's not going to work if it doesn't work. So I meant that to sound really profound, but in fact, it was really simple. But that's the thing, is if it doesn't work, then it won't work. So if I had tried, let's say, -2 right off the bat, and that didn't work, and then I tried 1, and that did work, it's not like -2 is going to work all of a sudden. But the reverse isn't true. So I want to check to see if 1 will work again. All right, so I'm going to bring these down. And I don't need to do the 0, that's the remainder. So that I don't need to do that. All right, so I'm going to drop this down. That's -6 plus nothing. -6 times 1. 13 minus 6 is going to be 7. 7 times 1 is 7. -2 plus 7 is 5. 5 times 1 is 5. -5 plus 5 is 0. Look at that, it works again. So that means I have a 0 of 1 and 1 again. So that means it's going to be squared, but it could be even further than that. I don't think it will be, because at this point we've got a quadratic on our hands. This is going to be -6x squared plus 7x plus 5. That's a quadratic. So at this point, I don't need to go any further. You can stop once you have 3 numbers besides your remainder, because then it's a quadratic, and you can use other methods that might be easier than using synthetic. You could still use synthetic if you really wanted to, but the rest of the zeros might be complex anyways. So let's see. If we do want to see if, so actually I'm going to rewrite this over here. If we do want to keep going, actually I do want to show you what that looks like if we do keep going, because you could. Then we would try something else. It looks like 1 will probably not work again, but something else might. And so at this point, because of the way synthetic works, you kind of have to guess and check. So I'm going to show you why synthetic is kind of hit or miss at this point. We kind of just lucked out by finding out that 1 worked several times. But here, can you see that? Yeah, you can, just barely. So that'd be -1, that's going to be 1, and then 1, and then 6. So I get a remainder, which means that 1 doesn't work a third time. So I do know that I only have 2 zeros of 1, which means I only have 2 factors of 1. Right? Now I could keep going, and I could try other numbers. But remember, I'm just going to be guessing around in the dark here until I find something that works. I could try -1. I could try 2. Actually, no, I wouldn't try 2. I would try 5 or -5. One of those could work, but I don't know for sure until I try it and just see if it works, rather than actually just factoring it. So actually, yeah. So I'm gonna move this down a little bit at this point, and we're gonna factor it. I think this will have some factors that works. Yeah, it looks like it. 3 and 10. So -30, which would be 3 and 10. I want to get a +7, so that's a plus, that's a minus. That's going to multiply to -30, and that's going to add to +7. Now, the way I'm doing it here, I would call this the Myers method. I didn't invent it, though. It just makes an M the way I draw it out. So I didn't invent the method, but it makes a little M the way I do it. So I call it the Myers method. It's actually not my favorite method. There's another method I use that is faster that I usually prefer to use, but this way works pretty well, so it'll be fine. -1. So I'm just taking out the greatest common factor of the first 2, and then I'll take out the greatest common factor of the second 2. Should that have been a +5 or a -5? Hold on. -3, +5, +5, -30. Wait a second. What's going on here? Oh, I didn't put the negative in front of the 6. There we go. Okay. Because I'm not getting 2x minus 1. I'm getting 2x plus 1. Okay, there we go. Then if I factor out 2x plus 1, I'm going to do this off to the side over here. If I factor out 2x plus 1, from both this term and this term, I would get negative 3x plus 5 left over. So those are my remaining factors. And actually, I'm going to move these because I just realized they were really close to where they need to be. Right here. Ta-da! Okay, so what are those as zeros? Well, you would set them equal to 0 and solve them. So 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1/2. That would have taken a while to guess because I normally don't try the fractions first. I just assume that they're going to be nice to me and make it a positive or a negative number. So, yeah, negative 1/2. And then the other one is if I subtract 5 from both sides, and then, can you guys see that? You can't. Okay, so x equals 5/3 is the last one. So it looks like they're all rational zeros. So I'm going to scroll back up so you can see the question again. It looks like all of the zeros are rational zeros, which means that they're complex. I mean, if they say complex, they're not necessarily looking for I, the square root of negative 1. So technically, all of the numbers that we got for answers are complex numbers. Typically, when you say complex numbers, you're thinking of stuff with I in them. But in actuality, every number you've ever encountered so far is a complex number. Every number so far. The only time that you would be dealing with a number that's not a complex number is if you decide to major in math. So just to give you a context there. So we have zeros of 1, 1, negative 1/2, and 5/3. A little redundant, but those are all 4 of the zeros. All right. So if you're looking for unique zeros, then there are possibly as many unique zeros as there is the degree of the function. But if you do count the multiples, then there are always the amount of zeros, complex zeros, is always going to be equal to the degree of the function. So that's it for that one. Hopefully that was helpful and you get an idea of how synthetic works and factoring and using this factoring method. If you're not the student that this was intended for and you want to see, because I've already shown the student how to do the different kinds of factoring, and they actually prefer this kind of factoring here. So if you want to see that other kind of factoring, I have other videos on factoring that you can check out on the channel where I show you how to do the different kinds of factoring. And in fact, I think the very first video I ever made, which might be a little cringe because I made it years ago. I mean, not that I'm like an amazing video maker now because I don't edit at all. But if you really want to cringe, you can go check out my very first video I ever made. Go into the videos and like search for like order of when I made them and then flip it. And that's actually a video on the other method that I normally use, which I call 2 truths and a lie, which I think is the name of the video. So if you want to laugh, if you want to cringe laugh, go check that out. But otherwise, hopefully that's been helpful, and you can check out other stuff on YouTube as well as my website, myersmathematics.com, which is in the description below. I have on there, on the main page, a little PDF guide that might be helpful for you. It's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. So go check that out, and hopefully that's helpful for you. And I'll catch you in the next video real soon. Blessings.